Hey, how you doing? My name's Elton and welcome to the show. So this week is all about continuous deployment using GitHub Actions to deploy containerized application to Kubernetes. So if you're new to the show, hey, how you doing? I'm Elton. I'm a Docker captain, Microsoft Azure MVP. I worked for Docker for years. I've written books about Docker and Kubernetes. This is my weekly show, which is a kind of live show, all about the container ecosystem, about patterns and practices, about best practices for using containers. Different theme every month. The theme this month is continuous integration and continuous deployment, and then different topic every week. Last week was all about continuous integration with Jenkins, how you can run a Jenkins server in a Docker container, how you can use multi-stage Dockerfiles to compile your application in containers and package it up in a Docker image. This week is all about the deployment side. So we're going to carry on from what we've done last week, which is kind of that kind of in-house owning your own infrastructure where you run Jenkins, you run your own Git server, you run your own Docker registry. This will move into an entirely kind of hosted infrastructure. We're going to use GitHub Actions as our automation server. So GitHub Actions will run everything for us. We're going to build on what we did last week. So we're still going to use multi-stage Docker files to compile our applications. But we're going to compile them in Docker images and then deploy them to Kubernetes and see how simple that is with GitHub Actions. So I'm going to switch over to this camera now, and everything else will be demos. And when I pull down my green screen and move my mic, I'm going to run my advert for you. So I'll see you in about 25 seconds. You're watching Elton's Container Show with your host, that's me, Elton Stoneman. These shows are live, unscripted, and unrehearsed. So if you like my style, but you prefer something a little more polished, then you should check out my courses on Pluralsight. Pluralsight's an online training platform, and I've got tons of video courses on there that you're bound to find useful. And if you prefer to learn by reading, then you'll be interested in my books, Learn Docker in a Month of Lunches and Learn Kubernetes in a Month of Lunches, which are both published by Manning. And if you just want to see what I'm up to, then you can check out my blog. And now, back to the show. Okay, and so here we are. So if you're new to the show, it's mostly demos. So I have a talking head bit at the start to get you interested in what I'm talking about, and then everything else is all on the GitHub repo. Where if you go to eltons.show, there's links on every episode to take you to the GitHub repo. All the demos I'm doing, there's a markdown file, walks you through what I'm doing, so you can see what I'm about to do as I do it. And you can kind of follow along with this stuff yourself if you want to. So the main thing we'll be doing this week is we'll be doing running a whole bunch of stuff in GitHub, and that gives you these really cool badges. So if you're running your applications builds in GitHub, you can get these little badges that you put on your README document, you put on your homepage to show you how well things are doing. We've got 3 versions of a workflow we're going to run in GitHub, just evolving that build that we're going to be kind of delivering up to Kubernetes come the end of the session. So the first thing is GitHub Actions. It's been around for about, let's see, a year now. The idea is that GitHub provides you the servers to run some automation, and you define what you want done in a workflow file, which is YAML. You've got to know your YAML if you want to do anything in containers, and that lives inside your GitHub repo. So inside here, if you look, this is the ECS repo where every episode is. Inside the root of the folder, there's a git.github folder, and inside there's a workflows folder, and there's all the YAML files that we're going to go through today. So everything that you need is inside there. And when you configure these workflows, you configure a runner, which is like a virtual machine that gets spun up and allocated to you. You can use different types of runners. There's Ubuntu, there's Windows Server. They have Docker installed, so all the tools you need are kind of already there. And there's a whole library of pre-written actions that you just plug into your workflows to do whatever you want to do. And we're going to look through some kind of evolutions of that. Okay, so that's the kind of basic stuff that we need to know. So first thing is, if we scroll down here, there's a bunch of links there from today's session. One thing I do need to point out, which I keep forgetting, is there's a Docker community all hands this week. So if you go on the Docker blog, blog.docker.com, you'll see the details about that. It's like there's a product update coming from the Docker team, and then there's a full-on Q&A. So you can ask any questions you want, and the Docker team will answer that stuff. And the rest of these links here are all about things from today. So first things first. If you want to do this yourself, you can clone my repo, but you'll need to put some secrets in your GitHub repo. So the way that actions work is they let you use environment variables for things that are sensitive, like your Docker Hub username and your Docker Hub access token, if you want to push images to Docker Hub. So you store those in secrets, they're not visible. Someone can clone your repo, they don't get your secrets. But so if you want to do this, you can clone this repo, create your own secrets, and we'll look at what those are in a second. And if you want to do the full thing, you'll need an AKS cluster as well. That's Kubernetes running in Azure. Okay, but let's get right into it. So the first workflow is based on what we did last week. So I've got a Docker Compose file, which is very similar to the one we ran last week. It's building those same three Docker images. So it's that astronomy picture of the day application. There's a Go website. There's a Java API which fetches the image details from NASA and caches it. And then there's a Node.js API which just logs access to the website. And the Docker Compose file is very similar. So I've got all these arguments for build number and build tag. I'm also adding the commit, which I can get from GitHub. And these file into the tag. So I'm including the build number in the tag when I build these things now. And this is all kind of, the fact that it's got GitHub in there is just the name of the environment variables. This is all kind of generic stuff with defaults in here. So just like if you saw episode ECS-C1 about Jenkins, I can build this locally with a bunch of defaulted labels in the image name and default tags, and everything will work but I'm not interrupting the developer workflow as I package this up to build in my CI system. So all kind of looks the same as before. The big difference is the YAML file. So last week we had a Jenkins file, and I said that you're just going to use your Docker commands inside there. So inside that Jenkins file, I've got Docker Compose build and Docker Compose push. And really, you're just the hard work is being done by Docker to compile your application, and you're just using your automation server to power the workflow. And that's exactly what we're doing here. So this is very similar to what I had last week. With GitHub Actions, you specify the events that trigger the workflow with this on section. So I'm saying on any push to any of these paths. So if somebody updates the source code folder, or if somebody updates the workflow YAML file themselves, actually that won't work, it should be .yml, so that will never trigger. Need to fix that. You can specify the specific paths that you want to push on, and that will trigger the workflow build. I've also got a schedule in here. So exactly as I said last week, you want this stuff building regularly, even if people aren't checking in changes, because you're now dependent on those SDK images that you use to compile your software. They're going to get regularly updated. So you want your builds to be regular to find out if there's an issue with any of those SDK things. And this workflow dispatch, which is like incredibly unhelpfully named, that means you can kick off the workflow manually from the GitHub website. There'll be a button you can click on to run the workflow manually, and to enable that, you need that workflow dispatch. Okay, and then I've got this job section. So you can have multiple jobs that fire off in parallel that do different things. In this first deployment, I've just got one job called ECS-C2 v1. The runs on is the name of the runner, the server that you're going to get, the configuration of the server. I'm just saying, give me Ubuntu, give me the latest version. I think currently that's going to be Ubuntu 18.04. Soon it'll be Ubuntu 20.04. If you go to the GitHub Actions website, it'll tell you all the software that's pre-installed. It's got Docker on there. It's got Docker Compose, a bunch of other stuff. You've got access to that VM. So if you need to install some other software, you can do that too. And then I'm following a very similar structure to what I did last week with my Jenkins file. So I got this verify section that just prints out the versions of the tools that I'm using. So this is about the simplest you get with GitHub Actions. You can have this run command that just executes as a shell command. If I was using a Windows runner, I could run PowerShell or command. I can specify if I want to use bash or the ordinary shell, whatever I've got on my runner. So I'm just going to print out my versions in there just to give me that kind of audit trail. And then I'm checking out all the source code. So you can run these actions that don't necessarily interact with your repo, but if you want to get the source code, and the source code here has got all of my Docker files and my Compose files, so I'm going to use that. So I need that. This is a built-in action that comes from GitHub. So I'm just saying, bring me in the latest version of all my code. Okay, and then I'm logging in to Docker registry. So Docker provide their own action. So these things are shareable components. So there's a whole library of GitHub Actions made by, anyone can publish them. So, and there's firms like Docker and Microsoft publish, respectable ones, and you can get ordinary ones that are just people fitting their own need to build their own image. You can run them as TypeScript, or you can build your own Docker image to execute your own steps. You've got a huge amount of freedom to what you want to do in here. The Docker one is providing me this registry login. So I'm going to log into Docker Hub, and I'm using the username and password, and they're coming from secrets that are in my GitHub repo. So this is going to securely log me into Docker Hub, so I can push my images without kind of leaving my password in plain text on a VM somewhere. So, using an official action is better than doing a Docker login manually in a shell command. And then the actual work is going to happen here. I do this build and push. I'm setting the working directory to be where the source code is, where the Docker Compose file is that we've just looked at. And then I'm doing Docker Compose build, Docker Compose push. Like nothing particularly clever in there. Inside the Docker Compose file, I've got those environment variables that are set by GitHub. So when this workflow runs, it will have the commit hash, it will have the build number, all that stuff that will filter through into my build arguments and then into my image labels. But I'm not really doing very much in here. I'm just using bits and pieces that come from, well-respected publishers. I'm getting my source code, I'm logging into GitHub, and then logging into Docker Hub, and then I'm just doing a Docker Compose build. So I'm going to kick this off, and then we'll see what happens. So if I open my GitHub secrets first to show you how this looks, I'm going to move this to a new window over here. Okay, let's show you this. So the way that GitHub Actions work is that some of what you're looking at is public. So if you look at the actions for my own six-side ECS repo, you will see all the actions that have been built. You will see all the iterations that I've been through trying to get the demos of doing exactly what I want to do for today. But some of this stuff you can't see. So you can't go and look at my secrets because that's part of the administration view. And I can't go and look at the content of these secrets. So I created 3 secrets: my Docker Hub username, my Docker Hub access token. They're the ones I'm using first of all. So my username is just my actual hub username. And then for the access token, if I go to hub.docker.com, rather than putting your password, Docker Hub lets you create these kind of one-time access tokens. So if I go to my account settings and zoom in here under security, you'll have these access tokens. You can create an access token for whatever you need. You can see it, and then you paste that into your GitHub Actions. And if you need to, you can kind of remove access here. So it's a nice way of giving automation things access to your repos or to your groups without having to kind of share your password around. Okay, so that's all stored in my GitHub secrets. If I go to my actions now, because I've already checked all this stuff in, those workflow YAML files, they're already in my repo. So GitHub knows about these 3 versions of my workflow. So if I click on version 1, because I've got that workflow, what's it called? I've forgotten. It's good. So it's so unhelpfully named. It's called workflow dispatch. Because I've got that workflow dispatch, I've got the option to run the workflow here. So this button means I can run that workflow. If you don't have workflow dispatch, which wasn't available when GitHub Actions first launched, there was no way to trigger an action manually. You had to, add a space to the end of a text file, commit it, and push it up to GitHub to trigger your action. So this kind of makes things a lot easier. If I click run workflow, I can choose my branch and click it, and it's going to start running. Now the UI here will show me in a second that started here. So I get my little, I suppose that's meant to be orange to show that it's in progress. And then I've got the jobs that break down as part of what's defined inside my workflow. So one workflow can have multiple jobs. I've just got one here that's going to do that Docker Compose build for me. This will take a little while, and eventually I'll get fed up and we'll go back to look at the code. But what it's doing here is it's fired up my VM. So I say you get allocated a VM. There's a whole bunch already to go. So one just gets picked off the shelf, given to you for a certain amount of time. As part of your ordinary GitHub subscription that's free, you get a certain number of minutes included, so you can use GitHub Actions for free. And then if you need more minutes, then the paid subscription gives you more. So it's the duration of your workflow that counts as the minutes that you spend. So anything that's happening during a job, the minutes are ticking up, and eventually you'll max out your free limit. But it's quite generous. I haven't maxed it out. I've been doing lots of stuff. So if we go down here, for each of these sections, you can get the details that come out. So I've got a whole bunch of stuff coming out. This is from my the build process for one of my applications. The UI doesn't always refresh, so sometimes you need to refresh it a little bit to see what's going on. But this is happening now. Where are we? We're up to my Go application here. So it's done the first part. So the Docker Compose is doing the build, and it's going to kind of run through. One of the disadvantages of this approach is that you don't get any caching. So my Docker files are kind of structured in a nice way, so make as much use of the Docker image cache as possible. But every time I run this build, I'm going to get a new, fresh virtual machine that gets allocated just for the duration of that workflow. It has no cache, like it's got a completely fresh install of Docker, so it doesn't know anything about the previous build, which was being nicely cached inside that Docker engine in the old VM that's then been thrown away and refresh ready for somebody else to use. So it's going to take however long it takes, usually kind of 3 or 4 minutes to do this full build. So we'll see that when the Go stuff is not too bad. In a second it'll get to my Java build, and that's what takes ages because it's pulling in all the dependencies from Maven and all that sort of stuff. And I can run this over and over and over, and it will always take that amount of time because I can't leverage the cache because of the way I'm structuring this. I'm just using this kind of nice, easy way to get started. Got my Docker Compose file. I just build up this really simple YAML for my workflow, but there's some kind of there's some inefficiencies here, which mean I don't want this to be my permanent way, because every time I do a build, I'll do all this fetching from Maven for all these things that don't change from one year to the next, and everything kind of takes forever. So let's just close this down here. It's still building, so we'll switch back to the code here. I told you I would get fed up. Okay, so that's what it's doing. It's doing that Docker Hub build as part of the push. When it's done all the build first, it builds them all in sequence, because this is standard Docker Compose build. It's going to build one image at a time. When it's built them all, it'll do the Docker Compose push, and I'm already logged in because that's what that action does for me. So it'll push everything up to Docker Hub. What I should see with Docker Hub is that it's just going to use the image names and the image tags that are defined in the compose file. So when I go and look at the tag for my access log, I should see the tag ECS-C2 and then the GitHub run number, which will be the number of the job. So if I go and look at this on Docker Hub, see if it's pushed it yet. And here we go. Let's zoom in. In readiness, no, it hasn't pushed it yet. So let's see what's going on here. I'm not going to sit and wait for the whole thing because I've got more interesting things to show you. But this is kind of proving the point that it takes a little while. We're at 3 minutes in. Oh, yeah. Okay. So it looks like it's just finished. Excellent. So you can see all of the details inside here. So in that build and push, that's where everything is. Thousands of lines of Maven stuff is all in there. And now if I go to my my Docker Hub, if that's updated, then here we go. So this is the one that's just been built. So the tag for my 6i, this is the access log repo. The tag is ECS-C2 So that was my GitHub build number 15. And we can see that it's just been pushed a few seconds ago. Okay, so that's cool. So that kind of works as expected. My other images will have the same tag. They've all been pushed there. It's a good way to get up and running and get moving to a completely free service that's fully automated. I'm not spinning up or managing anything myself. No build servers because everything's in my Dockerfiles that are multi-stage builds. So I don't need any SDKs or anything. That all comes with Docker. The only disadvantage is the kind of the speed that it takes to build things, and the fact that really I'm not taking advantage of all the other stuff that I can get for GitHub Actions with all those community actions that are available. So the next evolution here is kind of looking a bit more like it. So my V2 workflow here, I've got multiple jobs. I've got one job for each image. So I'm building them independently so that I can build them all in parallel. I'm still doing a similar sort of thing here. I've got the incorrect path for the source code and for the YAML file. I've got the workflow dispatch so I can run this manually. The name here is what shows up in the UI and in the badges. So this is my V2 build. And if I go down and look down here, it starts kind of in the same way. I've got one job defined for my access log, which is that Node.js component. It's going to run on Ubuntu latest. It starts with the checkout and then the Docker registry login. So it starts in the same way, get the source code, log into the registry using the secrets that are there in the repo. But then I've got these other Docker actions that are published by the Docker team. So as well as doing the ordinary Docker build, if you're not familiar, there's this alternative build engine called BuildKit, which is super optimized. It's been around for quite a long time. It's not the default in the Docker engine yet because you can imagine how many Docker builds happen every day, and BuildKit does things slightly differently. So you have to opt in to use it, and that's what this Docker action does. Wrong monitor. Let's go back here. This Docker action here that's called Docker setup build X configures the Docker engine that's come for free in my virtual machine. So my Ubuntu runner that GitHub provisioned for me, it's got Docker installed. What this does is it sets up that Docker install to use BuildKit with BuildX rather than the ordinary Docker build command. So when it issues those build commands, it'll go through the new engine, which is optimized to work in slightly different ways. And one of the things it can do is it can use a separate cache. So the ordinary Docker build commands use the image cache that's part of the Docker engine. So when you do a Docker image ls and you see all those images that are in there, part of that is your kind of image cache from the build, and they're stored in the engine. That's the only way to get there. But with BuildX, it's able to leverage a separate cache, and that's what I'm doing here. So I'm setting up again. This is a standard GitHub action that allows you to cache artifacts between builds, and I'm using that to this specific path and these keys to tell BuildX to use that for its cache. So I'm just setting up access to this GitHub cache, which exists between builds. It's just a temporary store for artifacts to save you doing that big download, or in this case, rebuilding the image every time. And then this is where the build actually happens. I'm using this Docker build push action. So this will build an image for me from a Docker file and push it to Docker Hub. I'm telling it the context, which is the directory where all my stuff is, and the Docker file to use. I'm using a different Docker file this time that we can go and look at in a second. And this is the important stuff here. I'm telling it to cache, to load from the local cache and to store to that local cache. So what we're going to do is we're using that folder, which is being managed for me by the GitHub Actions, as my layer cache. So each time I do this build, the image layers that I can reuse for the next build, they get temporarily stored in this GitHub cache. And then for the next runner, they get loaded in from the previous build. So when the BuildX runs, it's got access to those layers, and it can cache the build and it'll be a lot faster. And then I'm saying push true, which can push it to Docker Hub. And then this is the tag that I'm going to use. So right now I'm using a fixed tag. So I'm not adding like any suffix for the build number or the commit hash or anything like that. I'm just using a fixed tag for my V2. And we'll see in a second how we can improve that. And then for the other jobs, for the other images, they're exactly the same. So the image gallery, exactly the same. The only difference is the path that I'm using and the image name, and the same for image of the day, which is that Java API. So, but by splitting them out, I get all this duplication, unfortunately. So you can't really say that, here's a model of every step starts in this way and bring that in. But I do get the advantage. I can run them all in parallel, and I can configure them all in slightly different ways if I need to. Okay, so let's go and run this. Oh, I need to show you the Docker files first. So let's open this. The only thing that I've really changed inside here is my original Docker file had all these build tags in here. So I'm adding these build numbers as build arguments, and then I save them as labels. In the next evolution of this build, I'm going to get all that for free with another GitHub action. So I've taken that out in my v2 Docker file. It's just the things that I care about. So as one thing that BuildX can do is it can apply labels to the image without them being in the Docker file, which is a much neater way of doing it because my Docker file is describing how to package up my component. It doesn't really need to have those labels in there that aren't really anything to do with my application. So I've just cut those out. This is what we use for the next build. And again, if I now go back to GitHub, which I've got over here, and I'll open up my actions. So my V1 action eventually passed, so that's looking good. My V2 is the one that we've just looked at. Again, it has that workflow dispatch, so I can run it from the master. And what we should see is that bits of it are faster. It's not, the whole thing isn't faster for a reason, which we'll see in a second. So it gets added to a queue, and as soon as there's a VM available, it gets picked up. So this is starting now. It tells me it started manually. I can see here all the different jobs that are part of this workflow. And then for each one, they're all yellow, so they're all starting up in parallel. So what I can see here is the checkout's happening. There's a few more setup steps. So it takes a little bit longer because it does that BuildX stuff that pulls down the build kit. The build actually runs inside a container, then the layer cache, and then ultimately it comes here to do the build. Where's my build and push? It's here. And if I scroll down here, oh, here's the build and push. What we'll see is all this stuff comes from the cache. So all these bits, the npm install, which is the going and fetching the dependencies that my node application use, all comes from the cache. Everything comes from the cache because I've built this previously. It hasn't changed. So it's super fast. So by making my YAML more complex, but I'm taking advantage of what GitHub can do for me. And again, I'm using kind of standard GitHub actions that are available, that are published on the gallery, if you like. And I'm just kind of taking advantage of that. So by using the GitHub action cache, I can cache those layers between builds, and that speeds everything up. So the fact that I've got nicely structured Docker files means that, my builds are fast because I'm using that cache inside GitHub. If I refresh this, we'll see some of these others are kind of working their way through now. So the image gallery, that's my Go application. If I open this up, and again, the UI doesn't always kind of get super fast. We're coming to the end here. It's writing the layers. So the way that BuildX works is it kind of looks at each layer independently, and it can build them, and it has different targets. It can save them in your Docker engine, in your image cache, or it can push them directly to a registry, which is what's happening there. So my image gallery was pretty fast as well. And that's the post build. Let's look at this. If I scroll down, so not everything's showing here, but I would see a lot of this comes from the cache as well. The Java API, for some reason, it doesn't behave very nicely with the cache. So every time I look at this, it's still going to go and pull down all those Maven dependencies. So something is not quite right in the way that my Maven build is happening, but still it only takes a couple of minutes rather than kind of 3 or 4 minutes. So this will all happen, and it will push all those things up to Docker Hub. And access log was the quickest one, so this was already been built. And I should see here that fixed tag. Let's filter this by newest and refresh, because it should have pushed it by now. And it hasn't. Oh, that's good fun, isn't it? So my access log, did I use the right thing? So build and push. And towards the end here, it should tell me that it's written the layers, it's written the manifest. So that all looks good. Perhaps my UI just isn't updated yet. It's exciting, this one, isn't it? No, that's no good. What's it doing here? So I'm in my access log. Let's go back to my tags. Latest, these 9 minutes ago. Well, these things weren't 9 minutes ago. Perhaps it's something to do with the CDN that Hub uses. I've got loads of tags, and then we'll see all those in a second. Okay, we're going to assume that worked because it's not showing up yet in Docker Hub. But that could just be a caching thing with the UI, because I'm expecting that my V2 is already there. It's not a new tag because I already pushed it. So actually, perhaps it's down there. If I look at V2, 4 hours ago, it's not true. Last pull 3 minutes ago. So I think it has pushed it. It just hasn't worked it out yet. Okay, cool. So let's go back to access log there. And okay, so that's our second one. So that's an evolution. We're doing some more stuff there. We're taking advantage of all those different actions that Docker have. So there's a couple of links right at the top of this episode for the GitHub Actions that Docker use. And there's some really useful stuff in there to show you how they push those things together, how you can tweak them. That kind of complicated stuff that I'm doing with the cache, that's just boilerplate. So you just literally take this out and put it in your own YAML file. So there's nothing specific to my application in there. The only things that are specific are where the context is and the file name and the tags that you want to use. So everything else, standard stuff that you put in your YAML file, and it all works in the same way. Okay, and the next evolution, which is the kind of where things get a bit interesting, is that we're going to push to Kubernetes. So this is the CD part of it. People define CD in different ways. I usually use continuous deployment because that implies it's a practical process that happens as part of your software deployment. Whereas continuous delivery implies there's a whole workflow to make sure that you're continuously adding value to your applications. Whereas deployment just implies that it's being updated regularly, not necessarily adding any more value. So deployment is less loaded, I think. So what we're going to do here is deploy to a Kubernetes cluster. I've already got my cluster up and running, so let me close this down because I don't need that. Not that, not that, that. Let's try that again. So I'm connected to my cluster, which is in AKS, so it's an Azure cluster. All the notes for setting that up are in the repo if you want to check that out. I've just got a 2-node Linux cluster running Kubernetes version 1.18.10. If I look at all the things that I've deployed in there, what I'll see is I've got nothing running so far. I've just got a Kubernetes service. So everything's been kind of cleared down. I've gotten rid of everything from my previous demos. The only service that's in there is the Kubernetes API server. So not running any custom workloads. And now we'll look at what this new YAML file does. So my version 3 YAML file, what is that showing? There we go. Version 3 YAML file. Again, it's an extension of the previous one. So inside here, I've got the same job steps to compile my applications to build my Docker images. So they haven't changed. So I've got 1, 2, 3 in there for the access log, image gallery, and image of the day. So these are separate YAML files in this repo just to show you the kind of evolution so you can compare them and see what's what. Obviously, in reality, this would be an evolution of one workflow, which is the CI/CD process. So inside here, I'm specifying for my deployment section, this is the new section. I'm specifying that this depends on the other 3 having completed. So these jobs, each of them can run independently. We've seen that the build jobs all run in parallel. We had that in the last build. So with this build, these 3 will run in parallel. Let's do this. These 3 will run in parallel. And when they complete, then this one can start. So it's that kind of, they're all going to fire off. And when all of them have finished, then I'll do my deployment. I have to structure it like that because my deployment requires all 3 of those. So I'm going to make sure I've got the latest builds before I work on them. And actually, they're not the same. I completely forgot that. They've got some extra stuff in here. So they start in the same way. Check out the code, log into the Docker Hub, so that's all fine. Then I've got this other Docker action from one of the Docker captains. So this is like a community action. It's called Crazy Max is the guy's name on GitHub. It does Docker metadata. So what it does is it takes a bunch of stuff that it knows about the delivery from the GitHub repo. So it knows the commit ID, it knows the build number, all that sort of stuff, and it puts them as image labels into your Docker image and as tags. So it'll tag your image for you if you deploy it in a certain way. So what I'm doing here is I'm triggering this particular build from the push of a tag. So when I tag my repo with, this is v1.0 or v1.10, and I push those tags, that will trigger this build. So this is more like a kind of, we've done our continuous integration, everything's building, everything's fine. When we're ready to do a release to deployment, we will tag it with a version, push that tag, and that will kick off this build, which will do my deployment as well as the build. So that will, this GitHub action here, will add all the metadata and it prepares this kind of output. So it's going to use this as my base image name, and it will prepare some other image tags, including the GitHub tag, the Git tag for the version number that comes through. So it can work that stuff out for me, and it can use the Git commit and all that sort of stuff as well. Then I've got BuildX and the layer cache and everything else that's before. The only thing that's different here is instead of having a hard-coded tag, I'm using the output from that Docker metadata action. So the output from that action, you can pass things between the steps in your GitHub jobs. The output from that has a whole list of tags, including there's a colon latest, there's a colon v1.0 or whatever I have set up. It can do semantic versioning, all sorts of interesting fun stuff. And it puts out a whole bunch of labels too. that are OCI labels. So the Open Container Initiative, which has this kind of, it's this community initiative to keep the container spec open for other people to use. There are a bunch of labels that are recommended that you add to your images. It does all that stuff for you. So that's really nice to put into your build there. And again, it's just stuff that's coming off the shelf that I'm putting into my application. Okay, so that's the bit I forgot to mention. Then when all those things are completed, then this runs. Again, it's going to run on the Ubuntu machine. It's got a bunch of steps. Starts by checking out the application, because inside here I've got a whole bunch of Kubernetes manifests that are built into a Helm chart. And I'm using Helm to do my deployment because it lets you parameterize different parts of your application deployment. So we'll see how that looks in a second. Then I'm using this AKS set context. And what this will do is it will configure the Kubernetes command line, which Helm will use to connect to my AKS cluster, my Kubernetes cluster that's running in Azure. So I've got another secret set up in my GitHub repo with all the credentials that this action needs to connect to Azure to get all the information to connect to my Kubernetes cluster. So it will set up all the kube config stuff that tells the kube command line where to go for where the cluster is, where the manager IP address is, all the certificates, all that sort of stuff comes down into the VM, into the runner that I'm using temporarily just for this build, and it will be able to connect to my cluster. So I just provide a cluster name and the resource group, and it will set up my local kubectl command to go and connect. So the AKS ones, they come from Azure, so they're managed by Microsoft. There's a whole bunch of interesting ones that they have as well. This one is specific to AKS, but the one we'll use in a second, we'll use Helm to deploy, which can deploy to any Kubernetes cluster. So there are different ways of getting the context to connect to your Kubernetes cluster. Lots of different options for that. This is the easiest one if you're using AKS, and from then on you can kind of drop into kubectl deploy or Helm or whatever you want to use. Okay, the next thing I've got is I'm installing Helm. So the runner, the Ubuntu runner, doesn't have Helm installed by default. So it has the Docker command line and Docker Compose. We've already seen that because we've used those. It has kubectl, but it doesn't have Helm. This, again, is from the Azure team. It's just a really simple action that installs the latest version of Helm for you. There are parameters. You can tell it exactly which version of Helm you want to use, but the default is the latest stable one. So we're using version 3, Helm version 3. And then I've got some stuff like an audit trail like I had before, just to make sure that the tools that I think I'm working with are the versions that I want. So I'm just going to run a script to get the version of Helm and to get the nodes out from my cluster to make sure that I can connect to the cluster. And when I see the output, I'll see the list of nodes that my cluster is the one that I expect to talk to. Okay, quite a few more bits into this one, but remember we're doing a full-on deployment here. We're starting from source code in a Git repo, and we are deploying to a live Kubernetes cluster in the cloud. So there's a few separate steps to build up my images. They're all going to run in parallel, and now when they're all done, we're coming in here. We're coming to this bit where we're just setting things up at the moment, getting ready to do the deployment, and then we get on to do the deployment. So the next thing we need to do is work out the tag that our images are using. So when I use my GitHub tag, I'm going to tag this as v1.0. I'm going to push that tag up to GitHub. That will trigger this build. And my Docker build and push action will have a tag, which is, 6i/access log v1.0. Now that v1.0, that's the parameter that I want to give to Helm to tell it which versions of my images to use. But first of all, I have to pull that out myself. So the GitHub action that I use from Crazy Max, that works out the metadata for me. But if I want to get just the version number myself, I need to do this kind of ugly little bit of script that is setting the output to get from the GitHub reference. So I get the full reference from the GitHub build. There's a whole bunch of environment variables that GitHub populates for me. Buried within there is the tag that I'm pushing. This workflow will only run when a tag gets pushed that starts with the letter V. So I can extract that, and this will give me an output, give me a variable called tag, which has the value of my image tag, the same value that I'm using for my image tag. So it's a very complicated way of just getting that v1.0 to plug into my Helm chart. Okay, and then for the deployment step, I'm taking this tag, I'm setting up an environment variable. So the output from that previous build has got from that previous action that's got that tag number in there, saving it as an environment variable. And then the run, this is the actual bit that deploys the Kubernetes. I've already set up kubectl to talk to my cluster. I've got Helm installed. I've already checked out my repo that's got my Helm chart. So I'm just doing a Helm upgrade with the install and the atomic flag. So say to deploy it if it doesn't exist. If it does exist, do an upgrade. The atomic flag says make sure that everything works correctly. And we're just going to wait until that happens. So this command will sit there and wait until everything's been deployed, and it will roll back if there's a failure. And then these are the parameters that I'm passing. So I'm passing the image tag, which is that thing that I've just set up, and then the service port. What port do I want to use for the service that I'm going to publish? And then I give it a deployment name, which is coming from elsewhere in my workflow here, and then the path to the folder where my chart is. So if you're not familiar with Helm, it just takes your Kubernetes manifests, lets you parameterize bits of them, and then deploy them with Helm instead of with kubectl. And then the last thing that I do here is I just print this out, which is going to do a kubectl get service. This is the service that gets deployed as part of my Helm install. And I'm telling it to find out the IP address that gets published. So this is a load balancer type of service. When I publish this to Azure, or if I published it to AWS or Google Cloud, I would get a public IP address where my application is listening. And this is going to print out. So the final line in my GitHub action output will be the address to go and browse to the test deployment. So the final thing I'll do is I'll be able to click on that and see that everything's working. The deployment name that I've used up here, this is just, I can specify my environment variables at the workflow level, so all the jobs can work with that. So I'm going to be calling this apod test. Okay, so I think I'm going to kick that off now, and then we'll go and look at how the Helm stuff works, which will just fill in the last few gaps, hopefully. Okay, so if I do this a tag, so I'm already inside my repo, I'm going to add a tag. So that just works locally. When I push the tags, then that will send up the new tag to GitHub, my version 1 tag, which will trigger my build, and that will kick off my v3 build that will do my deployment for me. So let's go over to GitHub, because what I'm also going to see is that my other builds are going to be running as well. GitHub.com /ECS. Seems to be a different window than I used before. Go and look at my actions. So they're all running, but the only one I care about is number 3. So I'm going to kill these. And I'm going to kill that one too. And let's go and look at number 3, which is busy building now. So it starts off in the same way. So we can see the nice little visualization here. These 3 are all going to run in parallel. And when they're done, we're going to get to the ECS-C2 deploy. Those earlier stages are using the cache again, so they shouldn't take too long, apart from the Java. So the node one is just completed in 20 seconds. The Java one will take a couple of minutes because it does whatever it's doing to connect to Maven all the time. And now if I go and check what's going on in my Helm repo, in my Helm chart, then we can see what the missing pieces are. So inside here, I've got the templates for my chart. So I've got my API here. This is the node, this is the Java API. And the only thing that's really important in here, so I've got an IP address for the other components to talk to this component in a service, cluster IP. And then down here, the parameterized value is the image tag. So there's the image, which is my kind of 6-slide image of the day. And then I'm passing in this image tag, which is going to come from the parameters that get fed into the Helm install command. The default value for that is in this values, which is just going to be latest. And then I've also got a default port for my application service, the web application to go and browse to. Inside here in the web application, again, I've got the same image tag as a variable. So I've got a 6-slide image gallery with the image tag coming in from the values, but I've also got in my load balancer service up here, the service type is parameterized as well. And then the port is parameterized. It comes in from that Helm install command. So again, the reason for doing this is kind of once you move to Helm, you have to kind of deploy everything from Helm, because otherwise you're going to end up with 2 sets of charts. And you don't want your devs and your test environments to be using kubectl with 1 set of charts, and then production to be using Helm with a different set of charts. So when you move to Helm, it's important to be able to maintain that developer workflow. So when developers can just do a Helm install, and it will deploy, a load balancer type if you're running on Docker desktop, or you can specify, if you're using K3S, you might want to use a node port or whatever. So you can specify a different type of service and a different port as part of your install, but use the same chart, use the same manifest that are inside there. So for my actual deployment that I'm doing to Kubernetes, to AKS, I'm specifying way down here, I'm specifying that the service port is 80 because it's a standard HTTP port. I'm going to get a public IP address, and there's my image tag that I've worked out from the build that's got my tag in there that's being applied to my Docker image push. Okay, so I think we should probably be there now. This is looking good. So all those builds have happened. We're now on the deployment section. So let's look down here. It just says it's starting, which is good. I'm going to take a quick drink while that's happening. So remember, what happens here is, there's a pool of virtual machines that are running up in Azure that power all these GitHub actions. One gets allocated to you. You get it for a period of time. I guess it gets cleared down. It gets used for your job, and then it gets kind of thrown away, and a new one spins up. So there's various things that happen. That's why you get queued for all the steps of your job. So I've done these things here. I'm doing my set image tag. I've installed Helm. The verify section here should tell me what I've got here, the Helm version. And then that's the AKS, sorry, with the kubectl get nodes, with my 2 nodes that are running up in AKS. So that's looking good. This is the complicated bit that works out the tag. And then right down here in the deployment section, which looks like it's passed, I've done my Helm. The revision is 1. The status is deployed. That's all looking good. There's no test suite. Obviously, what's missing from this week is I'm not doing any of the tests. Last week, I showed you how to do a quick end-to-end test in your container. I thought this week we probably got enough going on doing my deployment to Kubernetes, so I'm not showing you that. But you can do exactly the same kind of thing. And there are GitHub Actions that will spin up a kind cluster inside your runner. So you can spin up a kind of a quick Kubernetes cluster, do your Helm install locally, and then run a bunch of unit tests against your kind of local deployment. That all gets thrown away as soon as you're finished. Okay, and then the last thing here is this IP address. So this comes out from checking my service. So we go and click on this. Sometimes, oh, there we are. That just worked. So my Kubernetes cluster had nothing to start with. Everything's been deployed here. The API must be working, otherwise the website wouldn't be able to go and talk to it. So that's all looking good. And then if I open up my let's close this down, and then open up this. So I've got some room. I've got a couple of commands just to make sure that everything worked. So if I check the labels for my pods, what have I got running here? I've got my, they've been running for 100 seconds. I've got my API, my APod log, and my web. So that's all looking good. And then if I look at the pod that's running my API, what we'll see here is this is the image name, image of the day, v1.0. So that's the GitHub tag that I applied. So when I push that tag up to the ordinary Git tag that I applied, to my repo, pushed it to GitHub, that triggered my action, which went and worked out that the tag that I was applying was v1.0, which got added to my image tag when I deployed it as part of my Docker action in that same workflow. So if I go back to my Docker hub and refresh, which one was I looking at? Image of the day. It says it's updated 3 minutes ago, so that's looking good. If I look at the tags and sort by newest, there we go. So there's latest, and where's my V1? There we go. V1 pushed 4 minutes ago. That's got the digest 2FA. And if I scroll up and look at latest, that has the same digest. So that metadata action that Crazy Max wrote is really cool because it takes that tag and it makes it v1.0, but it also makes latest refer to the same image. So you can have multiple tags for your image to kind of do that semantic versioning. That action supports full semantic versioning too. So if I done my tag of version 1.2.3, then I would have the tag 1.2.3 and 1.2 and 1 and latest all pointing to that build, all from that same action. So it's really kind of nice way to split that up. Again, there are documentation for that. That's all in the links from today's episode. Okay, so that's all looking good. And checking the GitHub tag is the image tag, which in fact it is. Excellent. So we're coming to the end. That's about it for the sessions for today. Either nobody has got any questions, or my combined chat window isn't kind of showing me the questions. So I'm hoping it's the former. Next week, we're going to kind of finish this up. So I talked last week that this is really an evolution about how your continuous deployment process works, where people kind of start with, I'm going to run Jenkins because, I'm used to Jenkins, but now I can run it in a container, and that's kind of cool because I can start that up really quickly. I can use these Docker multi-stage builds to compile with an SDK image, so I don't need to have a build server with a bunch of stuff installed. All that can happen inside containers. And then today is the evolution of actually, well, if everything is portable because I'm just using Docker to build my applications, then I can run that in GitHub Actions. I can run it in a managed service, which is either free to use or extremely cheap to use. And I'm not having to do a whole bunch of work to get there. So the very first evolution of my new GitHub workflow took my Docker Compose files and just ran them in GitHub instead of in Jenkins. And then gradually I've evolved that to take more use of all the other stuff that's out there. Those Docker actions that provide all the metadata for me. If you pull that image, that 6-side access log v1.0 image, you will see all the labels applied to the image, which come from the OCI labels that are part of that action as well. So Georgia says, does this work in Bitbucket? Not as far as I know. So GitHub Actions is specific to GitHub. It's not a generic Git thing. It's a service that comes from GitHub. I don't know if Bitbucket kind of has some kind of workflow as well. I know that GitLab does. They have an alternative workflow. All these things are kind of specific. So Jenkins file is specific to Jenkins. GitHub workflow syntax specific to GitHub. The way you define your workflow in GitLab is specific to GitLab. They're not really transferable, but the core of what you're doing, using Docker to do the builds and using kubectl or Helm to do the deployment, that is portable. So, your workflow really is just the structure about how you plug in all the tools, and the tools will be the same everywhere. So next we're gonna look at the kind of the next stage of evolution, which is a GitOps approach. So as opposed to what we're doing so far, where something pushes changes to your cluster, the disadvantage with that is that something needs to have like admin access to your cluster so it can make changes, which is obviously a kind of glaring security hole. What GitHub does is it reverses that. So the cluster itself is monitoring your Git repo, and when it sees there's a change, it will go and fetch the change and deploy it itself. So we're going to look at that next week using Argo, which is a CNCF project that does that stuff for you. So if you're new to that, it's a fairly kind of hot area at the moment. It's only really gaining traction in the last 6 months or so, and Argo joined the CNCF. There are other alternatives too, but CNCF project is usually a pretty good place to start. So we're going to have a walkthrough of that next week. We'll see how that compares to what we've done today. Hope you found this useful. My name's Elton. You'll see all this on eltons.show, and hope to see you again next week.